Right. Hello folks, this is the screencast for assignment number 2, and just to, as you're getting started, just make sure you have all the parts that you need. You have the 3 chips that you need. There's the AND gate, there's the NOT gate, and that's the OR gate. So just make sure you have them, the proper ones. Check the number on them, as we talked about in the other screencasts. And you're going to need your 2 LEDs for this, for assignment 2, and a bunch of wires, and of course your battery and the battery connector. All right. Okay, so I'm going to walk you through how to put together the half adder. So the first thing we're going to do is we're going to lay the chips down on the breadboard. So it's very important again to note the orientation of these gates, these chips. So the AND gate, you'll notice there's a notch right there, right? So that notch is very important. That tells you where pin 1 and pin 14 are. So I'm just going to lay down on the breadboard. Now I'm going to lay down the breadboard, and we're going to have the chip straddle the center, as we talked about in the other screencast. There you go, snaps in. So note that this central trough here separates this side and this side of the breadboard, whereas holes A to E in row 1 are connected, and holes F to J, row 1, are connected together. There's a wire that runs underneath each of those rows. They don't connect across that trough. Alright, so we've got the AND gate down. We're going to put the NOT gate in as well. We're going to leave 2 holes, 2 holes in between the AND and the NOT. So carefully finding those holes and gently snapping them in. There we go. So we got the AND and the NOT, and this is the way it's laid out in our assignment. So I'm just following what the assignment sheet says. You could really put them in any order you want, but I'm just going to follow as we've set out in assignment 2 sheets. All right, so then there is the OR chip, and there we go. So now we've got our chips laid down. So let's just take a look again inside the AND gate. So this is what the AND gate chip looks like. Note where the notch is. So the notch is right there, right? To the left of the NOT gate. Sorry, to the left of the notch in the AND chip is pin 1. Okay, and to the right of it, where it says VCC, that's the power. That's what we're gonna connect to the power from the battery. That's pin 14. Right? Ground, if you look at it, right there, is pin 7. And everything else is numerically. It goes from 1 to 7. And pin 8 is on the other side. Alright? Okay, so that's very important. So in this case, pin 1 is an input, pin 2 is an input, pin 3 is an output. And notice again that there are 4 AND gates in this AND chip. Right? 4. 1, 2, 3, 4. So it's important to know which legs or which pins of the AND chip correspond to the inputs and the output of the gates. All right. So again, note that, and we'll put that away. All right. So the first thing we're going to do with our chips are we're going to connect them to the power and the ground. So we'll get that out of the way. And for that, we're going to use the smaller wires that we have. So pin 14 of this AND gate is right here, and pin 14 of the NOT gate is right there, and pin 14 of the OR gate is right there. So what we're going to do is we connect it to this column, the outside column. So I'm going to go from that hole. Okay, so let's just look at that. So here we're connecting from that pin, that hole, to that hole, row 1, right, which connects to pin 14. Okay, so eventually we're going to connect the battery, the red wire of the battery to this hole, and that will make all of these holes going down on this column powered up, right? So let's do the same thing for the NOT gate. So we're going to connect the NOT gate, pin 14 of the NOT gate, to the same column. All right. Okay. And lastly, we're going to connect the OR gate to that power column. And just be careful and double check that you do have the right pin, right? Because if you're one pin off, if you're one hole up, for example, in this case, you're not going to be powering that OR gate because you're not connecting to the right one. So just make sure that you are. And if things aren't working properly when you're testing it out, double check those things. All right, so now we're going to connect the ground pins of each of the gates. Right, so we're going to start with the AND gate, so that's 7. And this time we're going to connect it to that column there. So again, notice where we did that. This is pin 7 of this chip, and we're connecting to that. So this is going to be the column that's going to be connecting to the black wire from the battery, and so that will ground the chips. All right, let's do the same thing for the NOT. Okay, so again, find an appropriate. Okay, I see I'm a bit off, so I'm just going to make sure I am in the right. Okay, good. Okay, so there's pin 7 of the NOT gate, and now we'll do the same thing for the OR gate. And there we go. So again, it doesn't really matter which hole you use, as long as they're in the same row as that ground, you're okay. Okay, good. Okay, so now we're going to look at our half adder circuit and plan how we're going to do this. So here's our half adder circuit. So as you notice, we're going to use 2 AND gates, one here, another one there, and one NOT, and then one OR. All right, so what we could do is choose which gates. Remember, there's 4 AND gates, there's 4 OR gates, and then there's there's 6 NOTs in the NOT chip. All right, let's start with the OR. So let's plan this out. Okay. So why don't we use the first OR gate at pin 1 to be the OR gate that we're going to use. So we're going to match that up. So if we're using pin 1, then we can just label this as 1. So that's the OR gate number 1. And this is OR gate number 2, pin number 2. And the output that corresponds to those inputs is OR gate pin 3. So in the end of this, all we're going to do is we're going to basically connect the dots, well, connect the pins to each other, but we pre-plan which gates we're going to use in the chip. All right, so let's go ahead and look at the NOT gate. So the NOT gate, pin 1 is input, so we'll use the pin 1. Pin 2 is output, so we'll use that. All right, so we use that. Okay, now let's look at the AND. So again, if you look at the AND here, we can use two of them, and we got to use two separate ones. So let us then choose the first one here. It's going to be pin 1, pin 2. Output for that will be pin 3. Okay. Now we have to choose another AND gate, and this time, well, we'll just choose something different. We're going to choose this AND gate here. So in this case, the input is pin 13, pin 12. Output is pin 12. 11. So input is pin 13, input is pin 12, output is pin 11. All right, so we're just going to put 13 here, 12, and 11. All right, so now that we've set it up, we can see that pin 2 from the NOT gate will connect to pin 12 of the AND gate. Right, pin 3 of the OR gate will connect to pin 13 of the AND gate. Right, and we'll just connect those. You'll also notice that we have an S and C here. These are the lights, and we'll talk about the lights in a second. So one of them will be the sum light, and one's the carry light. Right, and so pin 11 from the AND gate goes to the sum light, and pin 3 from the other AND gate will go to the carry. All right, so we've got our gates, we've got our diagram set up, and in the next screencast we'll put it all together.